Welcome to this CSIAC webinar. We are CSIAC, which along with DSIAC and HDIAC comprise the DoD IACs. Operating under the Defense Technical Information Center within the Office of the Undersecretary of Defense. Our mission is to facilitate interagency collaboration, disseminate scientific and technical information, and reduce redundancy amongst those who support the U.S. government. To achieve this, we offer several free services and contract vehicles, including monthly webinars. Our webinars are hosted by subject matter experts on emerging research and technology topics. Technical inquiries. Submit a question and we will spend approximately 4 hours digging into an answer for you, enough to give you a jump start on your research or project, all at no cost to you. Technical publications. Peer-reviewed reports covering critical technology areas, with focus areas including cybersecurity, software data analysis, and modeling and simulation, plus support from our sister IACs. We help navigate the vast landscape of scientific and technical information to give you a research boost. Visit our website to learn more.
Good day, everyone. Thank you for joining this webinar presentation. My name is Philip Payne. I am the technical lead for the Cybersecurity Information Systems Information Analysis Center, or CSIAC. Before we get started today, I would like to note a couple of administrative items. First, if you are dialed in by phone and would like a copy of the slides, they were posted to the CSIAC webinar announcement. You can go to csiac.dtic.mil/webinars and find today's webinar. When you click on it, at the bottom of the announcement, it will say download presentation. Second, all participants are muted, but feel free to chat using the attendee chat window on the lower right-hand side of the webinar screen. You can use that to chat with each other, and I'll be monitoring that chat as well. However, if you'd like to pose a question for the Q&A session at the end, please click the 3 dots labeled More/Panel Options to bring up the Q&A window as part of your layout. At the end of the presentation, I'll go over the Q&A. For the benefit of those on the phone, I'll read the questions out loud to the presenter. If you have any technical issues during the presentation, please have no fear. The full presentation will be available online. Please check back to the CSIAC website. Once the webinar is posted, the GoToWebinar button will take you to the YouTube link. With that said, I'll introduce today's presenter. We have Ms. Sarah Stander. She is the Deputy Director for the Developmental Test Evaluation and Assessments in the Office of the Undersecretary of Defense for Research and Engineering within the Office of the Secretary of Defense. With extensive experience in cybersecurity, information warfare, and developmental test and evaluation. She spearheads the development of crucial cyber DT&E policy and guidance, coordinates across OSD offices and the U.S. Department of Defense component engineering and cybersecurity teams to implement DoD acquisition cyber processes and guidance, oversees a team to analyze cybersecurity requirements and DT&E plans and data, and sponsors and advises key communities of practice. Ms. Standard is a retired Navy captain and U.S. Naval Army graduate and holds an MA in Applied Mathematics from the University of Maryland. Take it away.
Okay, hopefully you can hear me all right. I do want to correct one thing in my bio there. I'm the U.S. Naval Academy graduate, not Army graduate. I don't, beat Army. I'm sorry. My blood is blue and gold. I had to make that correction for you there, Phil. So thank you. I want to thank the CSIAC for having me today for this opportunity to explore DoD's updated cyber DT&E guidance. And thanks to those of you who took the time to attend today. All right, hopefully you're seeing the slides okay, and I will press forward. So first off, I want to set the stage for what is the status of DoD cyber DT&E publications. DT&E is in developmental test and evaluation. I am not on the operational test side. Maybe you're familiar with DoDI 5000.89, which is the test and evaluation. It's called test and evaluation. It is the overarching DT&E policy that is still in place today. And my organization, the Office of the Undersecretary of Defense for Research and Engineering, has developed the DoD manual 5000.UI. It doesn't have a number yet because it's still going through the process, the issuance process, but it is the the manual to implement cyber developmental test and evaluation policy that's outlined in DoDI 5000.89. The manual is still in legal sufficiency review. There has been some progress with the legal team in OSD. So it's in the queue for the final review by the lead lawyer, is what I'm told. And when it's published, you can see it'll be published, available online at the link there. And it specifies the what to do requirements for cyber developmental tests and evaluation for non-acquisition, pre-acquisition, and acquisition of systems and technologies. I'm happy to provide the draft if you want to see that, which has been cleared for public release, but it is subject to changes until it's formally published. The guidebook, so DoD Cyber DT&E Guidebook version 3, has published ahead of the manual, and it represents the how-to guidance, which technically is optional, but it serves as the best practices that the community has come together and agreed to. It's been heavily reviewed by industry and the various DoD components. We will update that guidebook once the DoD manual has its actual number so that we can change out the UI for whatever number it ends up receiving. We are also working with DOT&E on a combined DoD Cyber T&E guidebook, which will merge together our separate guidance, the version 3 for Cyber DT&E and the Cyber OT&E guidebook, which was published earlier this year. That will be an online interactive guidebook hosted by the Defense Acquisition University, publicly available. So it will bring together both of those guidance. All right. This is a snapshot of what I want to talk about today. If you participated in my DAU webinar, my Defense Acquisition University webinar, you're going to see a lot of similarity here. After I introduce the guidance, I'm going to try to ground the application of that guidance to a hypothetical system called the Emergency Enterprise System, or EES. My goal today with you is to discuss how the Cyber Working Group for this program, the EES program, would use the guidebook. So while this is a hypothetical system and hypothetical scenario, it is informed by real life scenarios, which I'm not going to specifically share in this forum. So although it's not a real system, I'm hoping that the practical application will help you understand how to apply this guidance. We'll talk a little bit about what's in the guidebook, about streamlining using digital engineering, and hopefully have time for Q&A. Okay, so there's 8 chapters. It's a pretty detailed guidebook, and those 8 chapters account for less than half of the guidebook, but they represent the core guidance. And I encourage those practitioners to take the time to read these chapters and also the manual. That's critical to enabling the implementation. Most of my focus today will be in section 2, 3, and 8. We also have appendices, which are the more in-depth guidance on these specific topics you can see here. We'll touch on applying almost all of these appendices today in this sort of application where we're functioning as a cyber working group. The appendices are meant to be applied and referenced throughout the cyber DT&E planning, well, really cyber T&E planning as you proceed. Some appendices include considerations applicable throughout the process, but most of them are really relevant when you're doing the continuous planning processes for cyber test. The CUI appendix that's mentioned here, Appendix L, is only available to those, obviously, who can use and store CUI. So you kind of have to have a CAC. Right now it's available online if you have a CAC. And the online appendix is our prototype with the Defense Acquisition University, and that's expected to be live in not August anymore, September. I got an update with DAU yesterday, so hot off the press. It'll go live to production by the end of September, and the joint the joint cyber T&E guidebook will be the next effort once we get this proof of concept live. I do want to let you know that the DAU websites are crawlable, but like web AI driven search engines will be able to find the guidance on the DAU website. So that's helpful if you have started to get addicted to the AI searching that you can use these days. All right, so some definitions. Cyber DT&E as defined in the manual is here. Its purpose is to support repeatable, objective, quantified assessments of cybersecurity and cyber resilience, which together to me are cyber survivability. That's the way the DoD has sort of partnered with the Joint Staff to express cyber T&E is cybersecurity and cyber resilience within a mission context, right? So we're evaluating systems or technologies under development, enabling an understanding of risks. And cyber DT&E does this by being an integrated component of developmental tests and evaluation, with the focus on verifying the relevant cyber performance and cyber functional requirements that the system should have. We'll talk about that more here today. Shown here is the definition for cyber DT&E, like I said, and then these other definitions, which are also from the DoD manual, I think illustrate important distinctions, which I think matter to the Department of Defense. So I used mission resilience in the title of the webinar. And here I have both operational resilience and cyber resilience as defined in the manual. To me, mission resilience is the broadest of all these resilience terms, and it focuses on the ability of DoD to achieve its essential missions despite any disruption, whether it's a cyber attack, a natural disaster, physical attack, blah, blah, blah. It's a focus on the functionality of missions, which is a combination of a lot of systems, not a single system. It's about having the redundancy, the alternative pathways, the ability to adapt to changing circumstances. You know, like a military base is able to continue launching aircraft even after they get a brownout, a partial power outage, or a hospital continues to provide emergency care during a hurricane. You can think of it that way. It encompasses both mission resilience encompasses both operational and cyber resilience for all of the systems that are involved in that mission and the people, the processes that enable the capabilities and support of the mission. And it's the ultimate goal. So understanding mission resilience readiness, I believe, relies on complex mission assurance assessments, which would be comprised of data from many sources, including cyber developmental tests and evaluation. So switching to operational resilience, this is about system functionality under stress. So each system and its operational resilience is a piece of mission resilience. I've highlighted the critical terms that I think are important in the operational resilience definition. During operation is in bold and mission-related functions is underlined here. These words matter. They are very important. They aren't used in cybersecurity, which I've provided the definition of here. They're not used, what I didn't provide, they're not used in the NIST definition for cyber resiliency. To me, they focus on a system and it's more than just cyber resilience. So I defined cyber resilience in the DoD manual as a component of operational resilience. I think it's a critical foundation, providing the capability to resist and recover from a very major class of adverse occurrences. It reinforces the importance of the test, fix, test approach we have in DoD manual 5000.UI. It's cyber DT&E isn't just about finding vulnerabilities. Certainly shouldn't be just about counting vulnerabilities. It's about evaluating how well systems can continue to operate even when those vulnerabilities are exploited. It's about assessing the system's ability to absorb the impact of an attack, recover quickly, and adapt its defenses as much as it can. This knowledge then informs the assurance assessments, which then inform the overall, assessment of operational and mission resilience readiness. So in the modern battle space, cyber isn't just where the fight happens, it's part of the fight. And therefore, the ability to defend and sustain operations in that domain, cyber resilience, to me, is a critical operational capability in its own right. Cyber resilience enables all the other operational capabilities in a system to function as intended. Without it, those capabilities are significantly degraded or entirely unavailable. Operational capabilities will not perform reliably without a robust cyber-enabled foundation. So a lack of cyber resilience directly impacts the ability to achieve mission objectives. And therefore, just like any other operational capability, cyber resilience requires dedicated investment in technology, engineering, personnel, training, and processes. It's not something we can tack on as an afterthought. It can and should be measured and assessed, cyber resilience. There could be, metrics like mean time to detect or mean time to recover, whatever you can measure. And you can also focus on measuring the system's abilities, its other functionalities when it's under attack. I think these metrics demonstrate cyber resilience as is a capability, an operational capability. So we need to quantify cyber performance in a mission or operational context. We have to elevate the importance of cyber resilience in our resource allocation and planning. Have the clear responsibility for maintaining and improving the cyber resilience. Integrate cyber resilience considerations into all aspects of engineering, operational planning, and execution. So I hope that I'm trying to set the stage here for you of where OSDRNEs, where my head was when developing the policy and the guidance that we are publishing. Okay, so cyber tests and evaluation is a long-term commitment of iterative activities throughout development and into sustainment. And that's an important point here because people don't often think that you have to test during sustainment. And in most cases, developmental test doesn't seem to be applicable in sustainment. But it is when you have changes that occur to a system. So the process, cyber DT&E, would start as soon as possible. Actually, cyber T&E would start as soon as possible in concept development. It should continue the entire time the system is existence. There's going to be a learning curve for the team so that they learn to hone their focus and priorities and efficiencies. Hopefully, I'll demonstrate a little bit of that through our example today. The manual and the guidebook are written with the expectation of the system having measurable and testable cyber performance requirements. And so you see my little note there on the right. That's an important presumption, right? We want to make sure we have these. So that's going to include cyber. Hopefully, I don't know if you can hear these jets behind me, but that's the sound of freedom. I'm down here at NavAir. These requirements will include cybersecurity requirements and cyber resilience requirements. And because of the evolving nature of the digital components in our systems, new vulnerabilities, new threat TTPs, software changes, for functionality reasons, for patches, all of these requirements have to be verified repeatedly and consistently to ensure that the mission capability is not at risk from the cyberspace threat actors or other cyberspace anomalies and events. Things just go wrong. So sometimes it's hard to find those just by software tests. You really have to think about how do we incorporate cyber DT&E into our testing. So what we mean by requirements, engineering requirements, technical requirements, not organizational processes for cybersecurity. These requirements are decomposed and allocated to the system components as measurable and testable performance requirements with technical performance measures the contractor can verify during development. Excuse me a minute. Needed to get a quick drink. These requirements have to be traceable to mission and included in the requirements verification traceability matrix. And that's really important because they become part of all the other requirements and they get to be traded off and considered in concert with all the other requirements. They're not specified as NIST RMF security controls, but in designing a system to meet those requirements, it is expected technical security controls will naturally get implemented to help satisfy some requirements that are specified cyber performance requirements. But we want to be able to ultimately measure the effectiveness and the performance of our cyber defenses, our recoverability, our detection, and the system's critical functionality, its mission capabilities when encountering cyber anomalies or threat delivered effects. If we wait until the system is delivered to stress the system in cyberspace, we will likely find issues we could have found and remediated earlier and at much lower cost. Cyber DT&E is critical to this. All right, moving forward, the guidebook aligns with the effort of moving fast. So these are just some key features. We're encouraging test management teams to adapt DT&E processes and permit intentional deviations so you can take the guidebook, you can customize, you can modify to your needs, but still trying to meet the intent. We're emphasizing the importance of coordinating across related disciplines like system engineering, risk management, software assurance in order to enhance the effectiveness of cyber DT&E. We have chapters and supplemental appendices. We already saw those. That's the organized structure. And in terms of an agile and iterative methodology, we're advocating for this agile, iterative, test, fix, test approach where you learn as you go, a continuum of learning as opposed to just one-time tests. This replaces our traditional event-based testing with more of a continuous assessment. And then as we focus on the emerging technologies and attack surfaces, the appendices specifically address, looking across the vast attack surfaces with various new technologies, including the intersection of cyber and electromagnetic spectrum. That's changed, it's no longer electronic warfare, it's electromagnetic warfare, in case you didn't know that. And artificial intelligence enabled systems, as we're trying to learn about cyber DT&E for those as well. We stress the importance of starting the DT&E process early to ensure that we have resources for mission-focused evaluations and informed decision-making. That data-driven decision support is really important. It's important to align the test activities with the decisions through acquisition and operational delivery, right? Promoting the use of shared data repositories so that we can have real-time insights. And that goes back to the digital engineering that we should really be moving forward, because that provides you an authoritative source of truth that enables the data to be used in real time. And the guidebook is also very much committed to workforce development. We have aligned the DoD's cyber workforce framework. We've aligned to the DoD's cyber workforce framework and digital workforce initiatives so that we can cultivate essential skills within the testing community and ensure we have a capable workforce for the future. All right. That's the guidebook overview. We're now shifting into our hypothetical system to help ground today's webinar for the practical application as a cyber working group of this guidance towards sort of leaning towards assessing resilience. So we're going to very narrowly focus on one requirement as we move forward. I do want to give credit to the Air Force who helped who built this system. Really, they defined this system when they were developing training for their mission-based cyber risk assessment process called mission-based risk assessment process for cyber. They developed training and they created this system to support unclassified examples of their process. So it's very useful. So the Notional EES is a cloud-based command and control platform that's installed into emergency vehicles like ambulances, police cars, fire trucks. And it's also used to bolster, well, it bolsters the emergency response management by having interoperable communication capabilities across all these different vehicles and the dispatchers. It helps to establish and maintain a persistent connection between all these different components that we have listed here. So you have the cloud-based integrated vehicle information and logistics data processing and management hub, or CIVIL, which communicates over cellular with the EM1 gateway units. So those emergency management gateway units, which enable the remote terminals to support authorized users. The EES has 3 primary missions that you can see shown here. And just focus on that bumper sticker. Compromising this system could directly impact the speed and effectiveness of emergency response, potentially costing lives. So that's how we can relate to it. And from a DoD mission perspective, we don't want to cost lives. It's a DBS pathway, Defense Business System pathway. And this table and figure are from the manual, DoD Manual 5000.UI. Notice that the activities called characterize attack surface and threat assessment You can see those here with these icons that are shown in the solution analysis phase. Notice the working group is established very early, and then you start prepare and plan activities as early as you can to inform the decisions as you move forward. But those two activities, characterize the attack surface and threat assessment, both occur before the mission-based cyber risk assessment, which happens just before functional requirements authority to proceed. ATP is authority to proceed. So that mission-based cyber risk assessment leads into that critical phase of doing the acquisition planning. It sets the stage for what are our requirements going to be, and we'll talk about that more today. The temp development starts around the same time as the MBCRA, and the RFP is not until after. So you can see the RFP doesn't even occur until after the acquisition authority to proceed here in stage 4, the green stage 4. Those are stages that we defined in DoD manual 5000.UI. So we defined 5 stages in the defense business system to help orient the activities you would do in DT&E. Typically, defense business systems involve a lot of commercial off the shelf. So a lot less new development is involved. In this case, a commercial cloud is involved. But here, the software itself, the EES software, is not COTS. People often think commercial off the shelf or non-developmental items do not need cyber DT&E. And the department is trying to lean, as you know, with our new administration, is trying to lead towards more COTS and non-developmental items for the department when we can. But cyber, the lack of evidence when you use COTS or non-developmental items of any rigorous cyber testing on these products means that the cyber developmental test is even more important in the DoD mission space when you're bringing those into the DoD mission. So anyone can buy those commercial off the shelf and non-developmental items. Anyone can identify exploitable weaknesses and not disclose those to the Department of Defense. Instead, use them against those who are implementing those products. So having the cyber developmental tests in a mission context is very important. Requirements are very important to have scoped what to test. And the mission-based cyber risk assessments are important because you cannot see into or manage the risk in the supply chains for these products, short of really the department getting some serious permissions there. All right, so in order to proceed through each phase of the defense business system process, the cyber working group has to be prepared to, demonstrate that they're ready to move forward. So the cyber working group has to provide assessments about their readiness along the way to inform those decisions. Okay, before releasing a request for proposal to industry, the chief engineer is going to have to create an architecture. So here is an EES architecture. Because it is commercial cloud hosted, the program and the EES software itself is not commercial. The program is using Agile software updates to the gateway, remote terminal, and other civil applications. You can see that on the bottom right here, the app developers and the administrators. This diagram provides details about the data employed in this system, in particular, the vehicle's health status, the location. Those are going to be collected via the CAN bus over here on the left with the vehicle. So you get the vehicle's location, get its health and status, and that's going to be sent and displayed to the operator in the remote terminal. So the operator will see that, but that information is going to travel across the cellular network into this civil environment. So real-time events, raw system data are all going from those vehicles and civil over cellular, and that data is being used by the vehicle dispatchers on the bottom here, the vehicle operators, vehicle maintainers for emergency response tasking, maintenance scheduling, overall capability optimization. So those app developers are going to build new or update existing digital solutions for all aspects of civil and the different components. There's real-time map and data traffic coming from third-party solutions shown here at number 8 on this diagram. And so hopefully this helps you understand EES and the architecture. And let's start by moving into applying the cyber DT&E guidance. I hope you're oriented at this point. All right, necessary first step. I showed it to you in the DBS diagram, Defense Business System diagram. You first have to figure out who's our cyber working group and charter that cyber working group. This is, again, before the solution analysis authority to proceed, really early in a defense business system. And while this diagram is depicting all the possible people that could be in a cyber working group, it seems like a large set of people, but you can have dually hatted people, and not all these people may be relevant for EES. It also is summarizing here in the middle the cyber working group's responsibilities, summarized from the DoD manual 5000.UI, and detailed a little bit more in the guidebook. I'm going to delve into these activities a little bit as using this hypothetical EES cyber working group. Okay. All right. I am noticing chat's very busy, so I'm looking forward to getting your questions. I'm trying to go as fast as I can. All right, Appendix A of the guidebook helps focus on staffing. So that's where this new cyber working group will start. They're going to try to figure out who do we need on our cyber working group. Each role is explained, describing expectations for how that role supports cyber DT&E. In several cases, there's some minimum desired qualifications, but this is not a mandate. Okay, the guidebook is guidance. For the EES, we should be looking for expertise such as cloud cyber testers, mobile experience testers because of the cell phone network that's involved, and CAN bus SMEs to understand how that EES data is going to be consumed. And when we're looking for government cyber test teams, the programs today can search in the joint over here on the right, the Joint Engineering and Test Enterprise Portal, which is a CAC-enabled website. There are service providers in there of government test teams, so that can help them with finding test service providers. All right, moving forward in the guidebook, we have in section 2, which is chapter 2, section 2, we have an example CYWIG charter outline. So you can see that here on the left. Don't have to follow it perfectly. Again, it's guidance. Gives people a place to start. And in the appendix, Appendix A again, we have an example of a responsible, accountable, consulted, and informed, or RACI chart. And we also have a downloadable version of that in Excel, so that people can, start to help their cyber working group members understand their roles. The charting, I mean, that's really an important thing, is how do I support, what's my job? What do I do, right? And so that's what these tools are intended to help with. Also in Appendix A, I told you there was a heavy workforce focus in this guidebook. We want our cyber working group members to be trained to be able to do their role, regardless of whatever their past experience is. And the Defense Acquisition University has developed training to complement the DoD manual 5000.UI in the guidebook. Whoops, went too fast. There's playlists for the DoD Cyber Workforce Framework qualifications. And so many cyber working group members, I believe, will align to the system test and evaluation specialist role. And so there are proposed courses. Well, actually, I think the courses have now been approved. At the time of publication of the guidebook, they were proposed. But I think that the 671 workforce role now has full playlists that are approved by DoD CIO that DAU offers for that role. Another role that is going to be common for the hands-on testers is the vulnerability assessment analyst role. And DAU also has playlists in place for that role. So it's important to get the training, and hopefully this information is useful in working towards that. The DoD Cyber Developmental Test and Evaluation Cross-Service Working Group, which is one of the communities of practice that I sponsor, they developed standards a while back for cyber vulnerability analysts, the hands-on testers. These test standards are available to industries, so we've publicly released those, but they're a little bit old, they're a little bit dated right now. And we think that the developer and the government cyber test team, so whoever the system developer is and whoever the government is, should satisfy those minimum KSAs. But again, that's not mandated unless it's put in contract specifically for the developer. They are being updated, so the Army is leading the development of that. It was a cross-service developed product. And they have two key components. They have organizational standards, which assess whether that organization that has these hands-on testers have the administrative capability to support the testing events, and that they're staffed with the qualified people and are committed to developing and retaining their workforce. The other piece is these specific standards for understanding and mastery of the vulnerability analysts, what they're expected to possess to execute cyber DT&E. And you can contact me, my team, for the current standards if you can't get to them from this link, because that is a CAC-enabled link. And the different stages here, apprentice, journeyman, master, and continuing maintenance phases, are all described in these standards. All right. I've lost my mouse. There it is. Okay. So now that we have a cyber working group chartered, we can ensure the participants know their roles. We have the support we need, the required training. We can establish proficiency levels for the test teams. And all of that is what the cyber working group focuses on at the start. Get all that administrative stuff, logistics all set up before they jump into scoping activities for cyber DT&E. So now that's where we're going to start to focus, is on the cyber DT&E process that the cyber working group is responsible for. And again, all of this is before solution analysis authority to proceed decision has even happened. Okay, here are notional, very notional, EES cyber requirements as part of the overall EES defined future capabilities. These are the cyber specific requirements. So industry should be provided better requirements. The requirements shown here are not what we should be delivering to industry. These 8 requirements just represent sort of high-level performance, cyber performance requirements for EES. They're not measurable or testable as written. And since we are focusing on resilience today, I've correlated some resilience focus areas that the cyber working group might be looking for in the design as they move forward. These generic requirements are as far as most programs go today, if they even have requirements. They may have the cyber survivability attributes established by Joint Staff J6. And if you didn't know, version 4 of the Cyber Survivability Endorsement Implementation Guide is in draft. It should be published soon by the Joint Staff. But our programs today often focus on aligning security controls from the NIST RMF risk management framework to the cyber survivability attributes and then get their ATO, and they believe that's adequate. But when we treat cyber sort of siloed off from the rest of the engineering or focusing only on the security controls, that isn't what we need. Again, cyber resilience is an operational capability. So in this case, the EES engineers have to treat these high-level requirements like other requirements they get, and they have to perform the analysis to decompose and allocate these into measurable requirements. It's not the cyber working group's job. The refinement of these requirements into allocated requirements for the request for proposal will be the culmination of the functional requirements and acquisition planning defense business system phase of the process, right? So the program isn't there yet. We're really early. We're still gearing up as a cyber working group, and we're getting ready to do that attack surface characterization, do threat assessments analysis, and a mission-based cyber risk assessment as we start to figure out what we want to test. We need a criticality analysis to support these as well. And criticality analysis isn't normally done for a defense business system. But these efforts will enable the cyber working group to advise the engineers what they should focus on for cyber. So once we get to that functional requirements and acquisition planning DBS stage of the webinar, I will share some decomposed and allocated requirements that are focused on this one that's in number 7 here, that's in bold. Okay, so we're just going to hone in on that one requirement, but all the requirements would go through the same process and same sort of analysis. So the cyber working group at this point is studying these high-level requirements. They're studying the ConOps for EES. They're collaborating with the chief engineer and the team from the chief engineer's office to inform a criticality analysis and a functional and mission decomposition. And they're going to apply their own analysis and share that as well. One of the more difficult concepts is defining a ConOps level requirements and then seeing these get allocated and decomposed. We're seeing that today with programs that they just don't see these as something they have to be allocated and decomposed. So I've ensured that these are written sort of that way with no measures, no clear way to test, and looking for the engineering effort to step up. But I just want to emphasize the cyber working group is a critical partner to inform that decomposition and that allocation. And that enables a continuous feedback loop to understand the requirements, advise on measures, and determine our test needs. So let's now focus on the cyber DT&E process that is described in the manual and in the guidebook. So if you were familiar with the 6 phases, there are no more. The DoD has adopted this continuum for cyber developmental tests depicted here. The cyber working group in the center of this is in a perpetual state of planning, as you see the blue ring on the outer edge, and refining those plans because things change in cyberspace. The cyber working group has to understand the current resilience posture of the system using analysis and test. So at this stage, their efforts center around scoping activities up here in the top right to understand what is going to be of importance and in order to know what to test, when they want to test it. Okay, so they have to monitor the changes throughout the system's life cycle, changes all the way until through sustainment. There's going to be software changes, architecture changes, upgrades, and threats are going to change, vulnerabilities are going to emerge, and attack vectors might change as different things are connected. Attack techniques might change. There's just a lot to think about. So that's the cyber working group's job, is to pay attention to these changes and keep track. All right, so we have these 5 processes. We go through planning, and then when it's time to actually test, there's going to be preparing, executing, evaluating, and reporting. That's mostly on the test team. So we're going to be more in plan today than anything, but we'll touch a little bit on the other stages. All right. Just as engineering is a recursive and iterative process, test fix test is iterative. Cyber working group needs to ensure cyber DT&E is recursive. That's not something people necessarily always think about, but the testing should be conducted through the decomposed system elements, especially on mission critical pieces, so that we can verify the decomposed and allocated requirements. And the engineers should be defining what these requirements are. At the highest level, we currently only have those requirements, right? But then they're going to go down to the system level. And this picture here is modified from what's in the guidebook. So at the system level, the engineers fully decompose and allocate requirements. And that means defining what each major system, so EM1 and civil, have to do to contribute to the overall system of system objectives. And then when they move down into the subsystem level, the engineers, again, in the program should be decomposing and allocating requirements to the subsystem level. That's where you get more specific about functionality, and then that's the gateway, the remote terminal, and then the civil components, subcomponents. Then at the lowest level is the component level, and those components, the hardware, the software, et cetera, you don't know those right now, so you can't really get there. But the cyber working group will consider the need for testing at each level. And in order to get started, they're going to do an intelligence assessment analysis. They're going to study the architecture and whatever available intelligence they have pertaining to that architecture. So here we have some hypothetical intelligence. Threat assessments for cyber usually aren't this good. Again, this is hypothetical, but the important point of what you should be picking up here in this slide is that the intelligence is focusing on the technologies, the technologies that are in the architecture, not on the specific hardware, software, not the system specifically, not EES specifically, and it's focusing on interesting techniques that have been observed. So focusing on cloud, on CAN buses, on FPG, I can't even say it fast, field programmable gate arrays, and on supply chains. We also have on the bottom right here, prior testing, hypothetically, from the government team, cyber DT&E team, that's a part of the cyber working group. So they have some published testing reports that describe the ability to remotely exploit CAN bus nodes and manipulate remote bus terminals. So all this is still early. This is what they have available to them. We don't have an RFP out on the street yet. Keep that in mind. But this is really good information, and this helps shape the processes that they're going through with planning, the cyber working group. But so based on that intelligence information, the cyber working group begins to narrow their focus for what threat-based testing they're going to need for the EES. They're thinking about using modeling and simulation as well, and they're interested in having concurrent cyber and non-cyber tests to be able to understand the EES resilience. So again, not specific to components or subsystems at this time. And they're going to capture this in their first draft of their cyber T&E strategy. That's going to be in the overall T&E strategy. Okay, so these are things they're starting to think about, thinking about simulation and what they can do and how they're going to focus on the attack surface. Now, since it's a defense business system and the criticality analysis is not likely to have been developed by the system security engineering team, and I don't even know if a defense business system typically has a system security engineering team, but the guidebook is encouraging these teams to work together on criticality analyses. And the Air Force, in developing their their MRAP-C process, they decided to create their own approach for functional and mission decomposition to support cyber criticality analysis in their process. And so this is the analysis they used for the EES in their process. So I didn't build this, they built it. They take the missions and they, in the first column, the primary, secondary missions, right? And then they identify and decompose those down into mission and safety critical functions. And very importantly, the next column over, the critical data associated with those functions. And then on the far right, they assign a confidentiality, integrity, availability, mission impact rating, where 1 is low impact and 5 is very high impact. And this reveals to the cyber working group that there are multiple mission critical and safety critical functions that are dependent upon the vehicle health and status, which includes location, and the software updates. So this is critical data that is going to help them understand the integrity of this data. This specific data could impact multiple missions simultaneously. You can see that traceability where you have the integrity as red 5 and you can trace it back. This analysis serves as important input to the mission-based cyber risk assessment. And they would revisit this information as needed during development. Okay, this is an extract from the Air Force's work again for characterizing the attack surface. This is also input to the mission-based cyber risk assessment. And I've extracted a portion of it here where I wanted to focus on some those key pieces. So here we have a technical feasibility score, technical rating column, where a 1 is not feasible and a 5 is very feasible for that technical attack, and a threat rating, of the ability to do that target that particular attack surface. And then the threat rating of 1 being no threat capability and a 5 being a confirmed threat capability. Together, these inform the likelihood of the attack surface risk. And when you consider the mission impact on the prior slide and the likelihood here, you can deliver incredibly useful information to the mission-based cyber risk assessment team. All right, I also wanted to emphasize in Appendix F, this that we have supply chain here as a really important consideration of this attack surface that should be explored in the mission-based cyber risk assessment. Those software updates from the vendors have another vector to impact that critical data and the mission critical functions. Okay. Cyber working groups, next steps. They're going to refine the test scenarios. They're going to start refining test scenarios, to develop some detailed test scenarios for the different test types. They're going to define acceptance criteria. They're going to collaborate with other test teams. But most importantly, at this point, they're going to conduct a mission-based cyber risk assessment to help them prioritize their testing efforts based on the potential impact of vulnerabilities identified in that event. This is still before an RFP has been released. We don't know what the software and hardware is in the system. Mission-based cyber risk assessments help us explore the resilience side of the cyberspace risks in an important way which the risk management framework doesn't address. We still consider any controls that might be selected, if there are any at this point, may or may not be, based on the architecture, or based on just compliance requirements that we know we're going to have. But mission-based cyber risk assessments can and should inform both engineering and test. And the manual, DoD Manual 5000 UI, provides the minimum criteria as shown here. This picture is from the manual for mission-based cyber risk assessments. The guidebook provides how-to guidance in Appendix G. And I want to emphasize that mission-based cyber risk assessments help non-cyber people or people that aren't in the cyber community understand or grasp why they should care about a technical finding in a test, or even in a concern from a mission-based cyber risk assessment. It helps them understand why they should be dedicating resources to fixing that concern, and why they should be verifying and test to verify those findings. That's really an important aspect of a mission-based cyber risk assessment. If you only have cyber people in the room, you're doing it wrong. You need to bring the operational side, the defenders, the maintainers, the people who don't necessarily live and breathe cyber like I do. They need to be in the room, because it's more about educating and helping them feel comfortable than it is about the cyber people, getting their cyber geek on. All right, so the cyber working group should perform that initial MBCRA again before the RFP is released. They're going to do another one after they have a developer under contract, and that helps to further inform allocating requirements and developer cyber DT&E. So the developer, the contractor who's going to build the system, needs to be doing cyber DT&E. Here we have a high-level attack description from the mission-based cyber risk assessment on the EES. Again, this was developed by the Air Force. I'm just, pirating or using their work here. And they're going to want to verify this particular finding in DT&E. The developer is going to. So you're going to capture that you're going to do this kind of T&E in your T&E strategy. The specific cyber DT&E tests needed to understand cyber resilience of a system will be different based on the mission, the capability, the architecture, the attack surface, the critical functions, the data. The MBCRAs help us to plan that and prioritize the testing and enable us to have more consistent and recurring assessments for those requirements throughout the life cycle. So we aren't just poking in the dark to see what we can find all the time, although that's fun. We have to be able to have a more rigorous and structured approach when we're doing testing in DT&E. So the cyber working group is now going to review and apply Appendix E to help them summarize the important aspects of the attack surface they are currently prioritizing. Appendix E is the characterize the attack surface appendix. And they the priorities could change. So as they're figuring out what's important to us on our attack surface, they could change as they iterate through and continuously are going through planning. But right here are the areas the cyber working group right now thinks need attention, right? So based on the attack surface priorities and the criticality analysis, the intelligence assessments, and the mission-based cyber risk assessment results on the right, they're starting to shape their testing priorities. This is very vague, it's not specific, and that's intentional. But this analysis has helped inform maybe modeling and simulation needs. What are we going to have to be able to have in the models? What are we going to have in our simulations? What test assets will we need in the future? What kinds of test environment, test infrastructure? What do we need to put in our RFP or our contracts? This is important analysis to do up front, because if you do it late, you're going to have gaps and you're not going to do a good enough job. So the cyber working group is now ready for the functional requirements and analysis planning phase. And this is where engineering should be getting real for this system. The cyber working group is going to advise the chief engineer on their analysis so far, their need for testable measures. They're going to emphasize to the engineering team that the specific requirement number 7, if you remember, we're going to look at it here a little bit more, but it's not about preventing compromise, although that is ideal, but it's about withstanding and recovering from it. And so they are going to want to focus on preserving vehicle location, reporting capability, basic vehicle status data, emergency communication. These functions they're going to be focused on as are important for resilience. All right, so we're in that phase now, the functional requirements and acquisition planning. And we have number 7, that high-level requirement here on the bumper sticker on the bottom. It's being decomposed just to the EM1 system here. So again, I'm very narrowly focusing only on EM1. And so the chief engineer is allocating the sub-requirements based on the cyber working group's priorities, like they're focused on degradation modes, how the system will function when it's compromised, failover, capability or redundancy, isolation, the ability to limit the impact of a compromise, and being able to recover, get full functionality back. So those are captured in these hypothetical requirements, but we're starting to see we can measure things now. And they continue on. The engineers are still going to continue to allocate those requirements down into the 3 components of the EM1 subsystem, the EM1 gateway, the 2 components, the M1 gateway and the EM1 remote terminal. So there now on the left is the gateway and on the right is the remote terminal. And these allocated requirements are now still traceable back up to that requirement number 7 and traceable to the cyber working group priorities and their testing needs so that they can verify this high-level requirement. And just based on this small set of requirements that we've talked about, the test teams, the cyber DT&E teams are now going to start to shape their approach or their ideas. And they're going to repeat this across all the requirements, which have been decomposed, right? So they're updating the T&E strategy, including the iterative MBCRA plans, and they're getting ready for another MBCRA after the acquisition authority to proceed decision with the contractor. And working with the chief engineer, the cyber working group will determine the testability considerations. Again, I'm still focused on the 1 requirement number 7. They're going to repeat this for all of them. So here's some considerations that the cyber working group might focus on and some things they might want to measure on the right. So this is just hypothetical. This is high level. The government has to consider other aspects, right? So there's other decomposed and allocated requirements for EM1 and civil. So for example, the CIWIG might focus on supply chain and commercial cloud. They can look at Appendix F for help with the supply chain, Appendix H for help with the commercial cloud. Those commercial cloud considerations might be under the shared responsibility model. What are the boundaries? Where's compliance? How about data security? How about identity and access management, network security? All the things you have to think about when you're dealing with the cloud. Access permissions, tools, data sensitivity. The cloud service provider RFP may be a separate RFP from the rest of the system. So that's something that the cyber working group has to think about. All right, capturing all this in their T&E strategy. Now it's time for them to think about what's going to go in the RFP and the contract for cyber testing requirements. Now, cyber performance requirements that are already in the system spec, we hope, and that's necessary for the cyber working group to have confirmed, that should drive verification of those requirements. So it's probably that verification of all requirements is already in the RFP, or should be. It's still advisable that the cyber DT&E contractual requirements maybe get highlighted. The cyber working group's gonna have to figure that out. But Appendix I in the guidebook is the reference for the cyber working group to help capture and tailor testing language for their focus, for what they've learned in their analysis. The appendix provides a list of known DIDs from the DLA Assist database. And so those are data item descriptions that go along with the CDRL. You can see in section C, the statement of work, the variety of tailorable elements that the guidebook covers. And in particular, the developer is going to need to be in contract to be a member of the cyber working group. And the appendix has also considerations for deliverables and incentives. It's worth the space. It's a long appendix, but it's worth the space I think it fills in the guidebook. All right, moving forward now, the cyber working group is going to be supporting the acquisition authority to proceed at this point, where this RFP is being released to industry. It would include any specific verification test types that the cyber working group has identified so far with the SEED rules to ensure that the results are delivered to the government. The test team supports the cyber working group by helping to define the test types that they might want to put in the contracts, identify where integrated testing might be desired, where the government and the contractor are going to work together. And again, these test types here, so on the left, the test types, those are from the DoD manual in table 2. And these are still focused narrowly on that one requirement. So I don't want you to think there's nothing else. There's another table coming up here in a second. And obviously, the cyber working group is not going to be necessarily in the RFP listing a very specific, a whole bunch of different test types for every single requirement. These are just examples to help demonstrate where the variety you could include in the contract, or you could just list, refer to the DoD manual. The point is to expand the aperture for testing approaches and seek more than vulnerability scanning, encouraging the proposals to think more comprehensively about cyber DT&E for the contractor. And then you have, this traceability of requirements to different test types might help the cyber working group with the integrated decision support key that goes into the T&E strategy, which I'm not covering today in the presentation. The cyber working group has to continuously be learning and working to understand the threat landscape. They don't stop analysis just because they release this RFP. It's a constantly evolving field, cyber. Testing and evaluating our systems against these emerging threats, it's a long-term commitment requiring continuously and ongoing research, development, adaptation. We're not trying to achieve absolute security. We're trying to build a system that is resilient, can adapt, and we are capable of mitigating the risks posed by those emerging threats over time. Here's some more of those different test types and traceability, which might be in the RFP and may not be in the RFP, but they might discuss these once they have the developer under contract and they're part of the cyber working group. They could have these conversations about the different types of tests if the contract enables it. So that's important. And then at the same time, the cyber working group is also planning for government acceptance testing upon delivery and any other government DT&E. So these are examples of government cyber DT&E. Again, these are more of those test types from the DoD manual. They might be putting this into their strategy. They're going to have to add things like when they're going to do these, who's going to do it, where, different tools. And again, these are still narrowly focused on that one requirement. Government tests do not have to be 2-week expensive events. I want to emphasize this. They shouldn't be. We should be doing component or subsystem level tests. They should be repeated periodically as things change to be able to verify that the requirement that component or subsystem has is still being met, and verify that we haven't broken those resilience capabilities, assess any new vulnerability, exploitability, and impact as we need to do. The cyber working group has to capture all these plans for infrastructure or any of their plans for test infrastructure in that T&E strategy. So Appendix J is the appendix to focus on where we discuss considerations for test infrastructure, whether or not they need to use cyber ranges. Are they going to need have a digital twin? Hopefully, yes, they will have digital twins. And as the cyber working group iterates through the planning, they have to refine their inputs into the RFP or the contract. So again, starting early is essential to limit the need for changes or not having the resources and the infrastructure they need. It is important to overthink. So the cyber working group has to also think about what test assets in addition to that infrastructure. And this has both of those kinds of considerations specifically for the ES that might be in the RFP. So these are just some examples, still focus on that one requirement about things that they might want to be including in the RFP to specifically drive the type of testing that they want the developer to do. Once in the acquisition, testing, and development stage, and by the way, we do have an hour and a half for this, right, Phil? I just want to make sure I'm still good.
Yeah.
Okay. All right.
We have to no rush.
Great. All right. So this is an example of mission-based cyber risk assessment scenario verification that's aligned to verifying some requirements. So we have, the EM1, the emergency vehicle system itself, which is composed of the EM1 gateway, the central hub for the vehicle data, the EM1 remote terminal, which is the operator interface, and civil, which is hosted on AWS, which I don't have depicted here. But an attack vector might be, this CAN bus, remote access to be able to manipulate the vehicle data directly. So they're going to do some planning and try to understand how they can do this testing and how they can, how the government can monitor the requirements to inform the extent of government testing that might have to be done. All right. So I'm not going to go into any detail in sections 4 through 7 of the guide, but that's where the details are for a test team. And so this test here, which is a supply chain attack test, which again, Appendix F is the cyber DT&E for supply chain considerations appendix. We are concerned, or the CIWIG is concerned about the software supply chain. They're concerned about compromised updates or patches being deployed from the developer environment into civil and then also into the EM1 components. So this test might be conducted by the developer or the government, and it should be captured in the T&E strategy specifically because it's a specialized kind of thing that will take some awareness and planning and maybe some different resources. So I'm not going into chapters 4 through 7. I just want to be able to help you understand what the cyber working group is thinking about at this point. The cyber working group now has to make sure that they have all of their information captured in the T&E strategy. So Appendix K is the appendix to help structure what to put into the T&E strategy to support the cyber T&E strategy. So all of the data and analysis now it should be readily available in the program's repositories to all of the authorized stakeholders for the cyber working group. And the T&E data that they're going to be gathering from the developer should also be in that repository and available to the cyber working group to review as it's being generated. So they will refine and update throughout continuous planning cyber working group activities, their T&E strategy. And it should reflect the mission context. The mission-based scenario testing will specifically focusing on scenarios impacting the primary missions, not just testing for the sake of testing. We want to make sure we're simulating attacks during operational scenarios, not just isolated system vulnerability focus. They have to define and track the resilience metrics, whatever those might be for EES, or what's specified in the requirements. They will look, of course, at the cybersecurity standards. That's going to be verified. They're going to have to take an iterative approach. They should capture that in the T&E strategy. But these are the main sections in Appendix A to help understand what kinds of content should be included in the T&E strategy. But it should explain how the program will prioritize fixing fixes that are impacting mission or affecting mission, mission critical functions, safety critical systems, critical data, all in mission relevant timelines. So that's a big focus. They should be capturing that. That's what their objective is in their strategy. All right, so the EES program is well on its way. They have an engaged and proficient cyber working group. They have a solid cyber DT&E strategy that's aligned to verifying measurable and testable cyber resilience requirements. They've reviewed and applied a good portion of the appendices and the content in the guidebook. Their continuous planning is really the most important aspect, and it's important for any program or any effort to conduct cyber DT&E. I focus today on the traditional defense business system acquisition, but the principles and activities the cyber working group starts and iterates on early and continuously are the same, no matter what pathway or non-acquisition, whatever you're doing. You do these same sorts of activities. So section 8 of the guidebook delves into the challenges with the cyber DT&E process that we have heard. And because the cyber DT&E process, while the 6 phases have gone away, phases 1 through 4 are basically this process. It's just written in a different way and depicted in a different way. Okay, so we've experienced in my years here with DT&E, we have seen how programs have struggled and we've heard the challenges. So we've tried to capture those in the guidebook. And then the chapter 8 also delves into digital engineering and model-based systems engineering considerations for cyber DT&E. We recognize that every single system is a snowflake. Even systems that are supposed to be the same will have potentially different versions of software in them, in the different platforms that they're supporting. The guidance is meant to be adapted and tailored. It's not meant to be ignored. So from the smallest, science and technology focused effort to the largest ACAT 1D program, we've deliberately developed this guidance to be applicable and tailorable. And so those challenges that can be faced if you're a smaller program, we tried to address those as well. We focused on a system that's going through program life extension or legacy, an in-service modernization program, a clean sheet new start program, all of those, this guidance has developed to be applicable and tailorable to fit them. We are focusing on exercising the process at a cadence and scope that you need, or whoever the implementers are, but we don't want anyone to skip integrating iterative planning and testing throughout the life cycle. Test and evaluation provides the best evidence of the system's resilience to those cyber threats or those cyber adverse events, because those test teams are your threat emulators. Other than asking China or Russia to come do your testing, this is the best you're going to get, unless you give your system to them, right, to go hack. So it's important to go fast, of course, to fail fast, of course, but also to recover fast. And so I've tried to demonstrate how those early efforts of a cyber working group, which would be driving the decisions for funding cyber developmental tests and evaluation, and also enable speed. If you start early, I believe, if you start early with that planning, you will get the learning curve going, and that will enable you to be better prepared to get the funding that you need to plan and justify for that funding. So let's look a little bit at the digital engineering content here, just very briefly from what's in section 8. But I believe by embracing model-based systems engineering and simulation that a contractor or developer can significantly reduce the risk of defects. They can improve system resilience. They can show the government that, and they can show them they're delivering a more reliable system. So the developer will have obviously some challenges, like model fidelity, cost of tools, licenses, integration complexity. I've been starting to pick up that the developers are investigating and working to mitigate these challenges now. Our industry partners are, you guys are. And that's good. So it's time for the DoD to write our contracts to require the use of modeling and simulation for cyber DT&E. in addition to other types of DT&E. We talk a little bit about ontologies in the guidebook, and hopefully that's not an obtuse term for you. If you haven't heard of them, please take a look at what we got in the guidebook. So for the EES system, the cyber working group should include a member of the modeling team if they are using digital engineering. And this might be an approach that contractor takes for the EES system, right? They might have these kinds of things in their modeling and simulation strategy to support cyber DT&E. All right. At this point, the cyber working group is functioning as a microcosm of the T&E, the Chief Developmental Tester or T&E lead's responsibilities, informing the program's risk, providing ongoing regular updates to the program management office, and the contract might need to get updated. But hopefully, if the cyber working group did their job, they have the right contractual requirements to be able to enable any interpretations or evolutions that are required. I'm not a contract expert, so don't ask me how that works. I can't tell you. But one of the big questions we also get is about software pathway and cyber DT&E. But just like Defense Business System pathway that I showed earlier, this is the DoD manual's software pathway table. So you can see now there's 3 stages for cyber DT&E as opposed to 5 that were in DBS. But the activities are the same. The table list of activities are identical. So they're common across all the pathways. They would be common for any effort. And the manual tailors the activities to each pathway based on the pivotal stages. The cadence and timing may vary. So how fast you go or when you do things might vary a little bit, but the activities are all still necessary. So you can see here in the planning stage for the software pathways, when all the planning activities that we just talked about today are initiated, is in that planning stage. You're going to do the characterize the attack surface, you're going to do the threat characterization, you're going to do a mission-based cyber risk assessment, and you're planning and preparing as early as you possibly can. So you should ensure that you have the right test environment, infrastructure, and processes in place to keep pace with the DevSecOps process. That's really important. Cyber DT&E is hands-on testing as opposed to the automated testing that the pipeline is doing. So while the cyber working group is doing the same activities, the cadence is going to be different here in a software pathway. You still need the engineering of requirements, and there may be, again, there's going to be all these automated tests, and the cyber working group has to understand how to apply those. But that's not enough for the quantifying the assessments of cyber resilience for this system, if it was to follow this pathway. All right. Hey, look, it's a summary slide. We made it. Collaboration is key, starting early, focusing on the requirements from the start to drive the testing and analysis. Requirements, requirements, requirements. Test needs that. We need an early and continuous assessment. By beginning your assessing the cyber aspects early in the life cycle and continuing iteratively throughout. Okay, this isn't a gate at the end, it's an ongoing process. And vulnerability identification and mitigation is the test, fix, test core. It's the core of the test, fix, test process. It's very important. You need realistic threat emulation and mission impact as a focus. You have to inform decisions, and those kinds of decisions are not just ATO decisions and RMF authorization decisions, but it's cybersecurity strategies, the engineering, and the design choices. Those are really important decisions that cyber working group should be working to inform. Okay, so adaptability is important too. You got to continuously assess changes to cyber risks that come from the software updates, the system mods, the threat changes, the technology changes. And the cyber working group is intended to help with planning all of that. In essence, cyber DT&E isn't just about finding bugs, vulnerabilities. It's about building trust in the security and the resilience of our systems, providing the information, the evidence needed to make informed decisions about cyber risk. It is a critical component of a comprehensive and proactive overall cyber strategy. And the cyber working group is responsible for planning and conducting adequate cyber tests and evaluation. Thank you. I know I went fast, but I welcome your questions if my team hasn't already answered all of them. So, Phil, back to you.
Yeah, thank you very much. Very comprehensive. Especially like the fact of the notional system being able to step through the guidebook. I think that was helpful. Looking at the chat, very active. A lot of teammates did put some comments in there. Just for sake of completeness, I'll read most of these questions out loud if they already answered in the chat for those who aren't following along. But I know we went a little long this month. This one was scheduled for an hour and a half instead of an hour, so I appreciate everybody sticking with us. So I'll just step through some of these questions. And Sarah, you just stop me when you have to go. But the first question we have in the chat is from Steven. He says, I believe NIST uses information security versus cybersecurity. Do you view them as one and the same, or is there a clear difference? I asked for there's an update to AS 9100 that calls out information security.
So, I think there is a difference. And I think that's why the Department of Defense has gone with cybersecurity as opposed to just information. Well, we used to use information assurance. Um, I I think there is a difference, and I think it's if we just focus on information security, that drives us just to the data. But I think there's more to think about, especially in cyber physical systems, weapon systems that DoD has. I hope that's short and sweet and helpful.
Thank you. Next question from Patrick. Operational resilience brings us to OT, operational technology. That points to physical cyber.
Hmm.
To that, from the design level, DoDAF must capture the tag data from KPIs and cyber physical requirements. So his question is, resilience should be physical cyber conversions in mission resiliency.
I don't disagree. I mean, I guess I agree. The modeling aspects that so I think DODAF is limiting. I think that's why we need to move into model-based system engineering where we're using system modeling language. And I I think that the if I mean you can still spit out DODAF visuals, but I don't think DODAF has necessarily enabled cyber modeling as well as we need it to. The MITRE defend approach, which is an ontology, they have built a Cameo plugin for those of you who do use Cameo, where you can bring in those defensive techniques that MITRE defend models that tie back to the MITRE attack framework. So if you haven't looked at that, I recommend you do, and also look at their CAD tool that they have. I I think the more we push ourselves, force ourselves into the modeling space where we understand the cyber physical aspects of the system and the physical aspects of the system and the safety aspects of the system all in the same authoritative source of truth, we will learn, and we will get closer to resilience like we want to. I don't think we have that all figured out yet. So I know that when we focused the cyber cross service working group focused on model-based system engineering and cyber DT&E, we found that the department was way behind, um, and that we didn't really have a whole lot of industry that was ahead on the cyber portions of model-based system engineering either. So I think it's a growth area. And I agree, Cameo is hugely expensive for small contractors. There are lots of other tools besides Cameo that to use for system modeling, and I encourage you to look at those. There's some free ones out there too.
Thank you. Next question from Alec. What is the typical life cycle time frame for a single operation which follows the protocol laid out in this presentation?
Uh, as I said in the end, that depends on the program's like if you're a software pathway, you're going very fast. So in the DevSecOps process, there's the threat modeling phase before you start the actual development. That's when I think a mission-based cyber risk assessment should be either done initially, or it should have been done during planning, but updated each time you go through the DevSecOps process for whatever is being built. So that's going to be very fast review. I think the cyber working group has to determine what their cadence of meetings are going to be. It might be weekly, it might be biweekly, it might be monthly, and hopefully not longer than that. Because if they start spreading out their discussions and their analysis into more than a monthly discussion, I think they're going to lose the momentum. But we have to see how these start to play out. I don't know that um, anyone's fully implemented the process yet. We're just starting to see some of our programs adopt now that the guidebook's published.
Next question from William. How does CMMC at the contractor play into the risk assessment?
Plays very well in the risk assessment. So CMMC is going to be something that the cyber working group has to learn about, and we haven't covered that in depth in the guidebook yet because I'm waiting to see it get implemented. Right, it's just now starting to get out there and get implemented. But I think about the cyber working group taking a look at their attack surface and the critical components that are in their system and the critical functions and the cyber terrain that leads to those critical components and those critical functions. So the cyber path that an attacker could take. I think they have to look at who the suppliers are along those paths and understand if there is a developer who's supplying components into that path, understand the CMMC level for those suppliers. That's going to have to be something they get into their contract language up front for their prime contractor, so that that can get flowed down so that they will be able to get the visibility and understand who is building their critical software or their critical hardware, or those software and hardware that are on the path leading to where the critical components are. So hopefully that makes some sense.
Next question from Todd. How does cyber DT&E align with initial operational capability of a system? I would imagine cyber DT&E would be a component of the IOC effort.
Yes, it should be. I would agree with that. The cyber DT&E should be exercised by the contractor all the way until they deliver it, and then the government has to do government acceptance cyber DT&E, and then the government is going to have to iterate through maybe integrated cyber T&E, where we have government OT and DT happening up till IOC. And then after IOC, I believe there's going to be changes that occur, and there should be additional cyber DT&E by whoever's delivering those changes, if it's software and hardware, and by the government when they accept it. And if I'm not answering your questions on point, or I'm not getting at what you were asking, then please re-ask.
Thank you. Our next question is from Gavril. He says, I have in mind two cases or better issues for the run concerning cybersecurity. One is the need to isolate an AI model offline during operations for sensitive reasoning output assessments. And the other issue is what should be done for legacy systems that will be exposed to quantum computing as password cracking. Can you elaborate on these issues, please? If I recommend sensitive systems to operate in deaf mode, would that be the right solution? Currently, I think that's the best solution that I can offer.
It might be. So those are outside the scope of tests specifically. Those are really important choices and decisions that have to be, and the cyber working group should understand which of those, like if you're going to have the AI not be operating in isolation, or it, yes. So I think that would have to be a case by case analysis, understanding the operational environment and the mission space and the critical functions involved, the critical capability that's being delivered, and whether or not there's another system that's coming in. But for legacy, so we understand legacy is a challenge, especially as quantum is coming, and the department is looking at all of that and taking into account modernization for cryptography. I don't have the answers for you. I think that's more of a CIO specific question. and I'm not involved in those decisions right now. So I'm not sure I can necessarily answer to the level you want me to.
Thank you. Our next question is from Frank in regards to the Joint Staff Strategic Cybersecurity Program. He says, was SCP successful at incorporating the existing corpus of cyber test data?
To my knowledge, the SCP has used whatever data that system, the program office for that system provided them. And I believe if the data was provided, it was used. I'm not sure that they were provided all of the data they should have been provided from test. And honestly, the amount of cyber DT&E that our programs have done wasn't enough probably to have moved the needle for SCP assessments. Hopefully this new approach that we're taking will evolve into greater corpus of data to inform those kinds of assessments. The SCP is moving to a more of a mission thread approach as opposed to an individual system approach. So that will also change the kind of data they need and look at.
Thank you. Our next question is from Gary. He says, testable cyberspace defense requirements appear to include those where finding a vulnerability is not necessarily a failure. The rationale is we expect to deploy vulnerabilities, so having a vulnerability cannot be, by definition, be a failure. Challenge. What is the testable requirement considering that vulnerabilities will exist and the test event is highly dependent on a test team capability and experience? For example, adversary emulation.
Yeah, so agree with the whole premise there up front. We are assuming that there will be vulnerabilities. And it comes down to not all vulnerabilities are created equal. So the test teams are still going to scan for vulnerabilities, they're still going to look at them, but they have to understand in their adversary emulation if they can exploit that vulnerability in a mission relevant timeline, if exploiting that vulnerability in the mission relevant timeline causes any kind of a a function, observable mission impact in the mission relevant timeline. If it can't do that, then that's not a finding, right? That's not significant enough to spend the resources to go address that vulnerability. So it has to be exploitable, accessible, exploitable, and mission impactable, new words, in a mission context, in the mission relevant timeline. And you also might have to think about, well, is there another system that can come in and fill the gap if this does impact? And that's that mission thread context that has to be considered. So again, I'm very much opposed to counting vulnerabilities and tracking only vulnerabilities. Those aren't good metrics, nor is the declaration that I got root a good finding. It's how long did it take to get that root access, and what can you do once you're there, and is that mission relevant at all? Over.
Thank you. We're a couple of minutes past 1:30. I believe we
Oh,
addressed most of the questions.
great.
So I would like to thank Sarah and DTEA again. These slides are up on the website. That link is in the chat. Please check back the CSI website if you would like a copy of the slides. There was also a link to the guidebook put directly in the chat as well. Feel free to reach out to CSI or Sarah directly if you want a copy of the guidebook. On the way out, please fill out the survey. We actually do look at those responses. We're always interested in hearing what you guys have to say. This was a great presentation. I think it was worth the extra half hour today. Hopefully you will join us for next month for the August edition of the CSI monthly webinar series. And hopefully everyone has a good day. Thank you.